perpendicular components. So resolve this VB. But sir, we don't know VB. After solving that, we'll get the velocity vector VB. Then calculate the angle made by velocity vector with the line joining the AB. You'll get the velocity of point A. After getting velocity of point A, then get the angle made by the velocity vector with alpha, with the line joining AB. That I'll call alpha. Then I'll get the angular velocity. Sir, if I do for AC also, will I get same answer? Yes, it is.
Sir, could you repeat what you have done for this question, sir?
This line AB, A and B are the 2 points on rigid body. No, we know line the distance AB, we know it. That is given. From the equation 1, 2, 3, 5 solve, I'll get the velocity of point B. Then I'll calculate the component of velocity of B along the line joining B. I'll get the velocity of point A. Then I'll calculate the angle made by velocity of point A with respect to line AB. I'll calculate alpha and beta. Then I will use the basic definition, relative angular velocity. How you define? VA sine alpha minus of, because they are in opposite. But sir, what happens if it were in this direction? Later on you change it, no? What is then that one? So I'm just assuming somewhere like this. If it were like this, then this should have been positive. Anyway, the sign will give us. I'm just giving a brief idea here. So VB sine beta, this is VA sine alpha. And we know distance, you'll get angular velocity. What is this omega? Omega of what? But sir, actually it is not rotating about A or B, no? And what you calculate is angular velocity of B with respect to A. But what is the question asked? Angular velocity of the rigid body. So how it is justified? This angular velocity, how it can be angular velocity of rigid body? Yes, in fact, this omega is what? Angular velocity about the center of mass of the rigid body. But sir, you brought relative angular velocity. As you go back to again circular motion, calculate velocity of any one point about other point, and it will be equal to angular velocity about the center of mass of the rigid body only. Okay, the basic circular motion is what? See, there is a core idea that has to be applied here. I'll give the answers, cross check all this one. This will be 1/4 radian. And the velocity of points, you have to work out. And the velocity of point A will be okay, these are the answers. Okay, no. Now this one problem I just left it, you can work out here. So where the instantaneous center for this will be, I think the diagram which is being displayed. This I think where the instantaneous center will be. So this is the and this is a rod. What is velocity of descent is VA that he has given. So now he's asking calculate the angular velocity. What is the simplest idea? Calculate the angular speed of the rod at this instant. There are two approaches are there. Directly you know length and you know this angle. And theta is also given. If you know theta here, can you bring this angle, say phi? He's asking to get the angular velocity, no? So what to do for this? Any method? So let me take this is X, this is R. Apply sine rule. So 120 degrees, theta 20. Theta is how much given? 20, and this is 120 degrees. What can be the angle phi? So that we can get easily. So applying the sine rule, so what happens? We'll get the relationship. So what is the sine rule says? L by sine 120 degrees is equal to X by sine phi R by sine theta. So what information we have? Length of L We know this. So we'll get relation between x and sine phi and that one. What is dx by dt here? So we'll get relation between x here, no? What is VA? Dx by dt only. Angular speed of the rod. So shall I write dx by dt as omega, angular speed of the rod? With the time, what happened to theta decreases or increases? It in fact decreases. So what is the angular velocity of the rod? Will be minus dt. No need of instant center. No need of instantaneous center. So directly you can bring the omega. So differentiate this. So bring theta. So calculate r from this particular thing. So omega equal to what? D theta by dt, that one. And dx by dt is what? VA. So I'll write it here. I think this is just a basic sine rule or circular motion idea. If you solve by instant center, how it should be? If you solve by instant center, how the problem should be? The problem, what will happen, will take shape like this. Say several approaches. It's not that you should solve what teacher says like that only. No need that one. So here there's a rod. No. Let's come for instant center. How the velocity of descent will be like this. So where the instant center will come somewhere here. Now what is the velocity of descent? The velocity of descent should be along the rod or along the point B. Who will answer this? The velocity of this point will be velocity of point B will be along the rod or along the inclined plane. It should be along the inclined plane, no? Am I right? So it should be in this direction. Because descent will slide along the incline. Descent will slide along the horizontal surface. Now from here, you bring perpendicular thing. Call RB, RA. With what angle velocity you are saying, no, that omega, that same omega is what? This one. So shall I use this method? Yes. Your task question like, so this omega you brought about what point? From d theta by dt I brought it, but not like it's not rotating about A. It's not rotating, it's rotating about instantaneous center. Able to manage this? Any good questions can be asked. So I'll just, okay, we'll stop it here, instant center. We'll go for next concept. One more basic idea, rolling one. Oh, things are coming. We'll discuss tomorrow's class some remaining thing. Let me, there's a rigid body